In this video, we're going to take a look at another Python structure that's available in many other object-oriented languages, like C++ and Java and PowerShell. And that is the concept of a class. A class is sort of an extension of the idea of a function. It's a way to modularize your code, but it can do more than a function. Whereas a function can have its own data members, a class can also have data members. It can have variables inside of it, but it can also have dozens of functions and methods that correspond to that class. Whereas a function is sort of like a recipe or a to-do list, a class combines what an object is, the attributes of an object, with what an object does. The attributes would be data members or variables, what an object is, and what an object has, and accessor methods and functions inside the class would be what the object does. So it's basically a blueprint, and it more closely models a real-world object. I'm not just a collection of attributes. I'm also a collection of methods. So I might have an age, and I might have a gender, and I might have a name, and I might have other attributes that apply to my existence, to my personhood. But also, I walk, I sleep, I eat. I have all of these methods that correspond to being a human, to being a person. And so that's the idea behind a class, is that we encapsulate more closely a real world object. And that means combining what it is, what it has, with what it does, its data members and its functions. To define a class in Python, you just use the keyword class here. And in this example, we're going to define a monster class, okay? And up at the top, we would list some data members. And these data members, these are variables that pertain to the class. And once it is instantiated, that is, once we take this blueprint we're defining and we actually set aside memory for it and build it, we can then access these data members via the dot operator in Python. So we have name. A monster can have a name: health, defense, attack, dexterity. All of these are data members, values, objects that would be stored inside of a monster, that would pertain to a monster as we define it in this monster class. So this would be maybe for a game, if you were going to build a Godzilla or a Mothra. If this were going to be something like an employee database, or an herb system, resource management, or an enterprise type database, it could be an employee class. And an employee would have a social security number, and maybe a mobile, and a first name, and a last name, and an employee ID, things like that. So, the sky's the limit. It could be an automobile if I were an automaker or an auto factory, and I could write the automobile class, the Toyota class, the Mitsubishi class, whatever. These are data members, and then if we come down here, this would be a member method. So display monster, we're combining what it has, what it is, with what it does. Being able to view a monster means being able to view all of its data. So in this case, the method or the function would just display the name, health, defense, attack, and dexterity. So that is our class definition. That's how we, now the class definition, it's just a blueprint. It's just like when you write a function, it doesn't do anything until you invoke it or you call it. When you write a class, it doesn't do anything until you instantiate it, until you allocate memory and you build an object, an actual object from that class. So this isn't an actual monster yet. It's just a blueprint for a monster. It's a definition. But if we go here, then I can say generic monster equals monster. When I do this, I'm calling what's called the constructor. And we'll look at an example later where we actually define a constructor, which would be underscore, underscore, init, underscore, underscore. But in this case, this is an implicit call to the constructor. There's a built-in default constructor if I don't define one. And it just calls that and builds this class of object. So here's the blueprint. Doesn't do anything, but then here we actually set aside memory and we build the object from the class definition, from the blueprint. Once we do, we can use the dot operator. All right, so Godzilla equals monster. I'm building a monster object, and it's going to be called Godzilla. The instance, I instantiate it as Godzilla. And then using the dot operator, I can call different data members from the class, and I can set them. So in this example, I'm setting them, all right? And then I create another monster. We'll call it Mothra, the instance, right? We instantiate it as Mothra. The instance is Mothra, and I'm setting some more data here. And then I'm just going to call generic monster, display monster. And I'm going to call the same method on Godzilla and the same method on Mothra, so that you can see that each object that we build from the class has a completely different set of data, okay? Whatever we assigned or whatever we set those data members to, they each have their own unique set and instance. Let me pull this up here, and we'll hit F5 and run this and see what happens. Okay, and let me just pull this up here a bit. Okay, so you can see generic monster has a set of values different from Godzilla, which has a set of values different from Mothra. So, we define a class, and then once we define it, it's got a combination of data members and member methods or functions, combines what it is, what it has, with what it does, and then we build the class, we instantiate it, we, give it resources, give it memory. In this example, we're going to take this idea of classes a bit further, and we'll do some manipulation with instantiated class objects and their data members and calling their member methods and so forth. Okay, so we're going to import from OS system and name. We're going to use a little bit of randomization here, generate some random numbers. So we'll import random and we'll import time. All right, so we have some globals, player1 and player2. And we're going to define a monster class, right? It's got these data members, health, defense, attack, dexterity. The monster class starts out its generic monster, and it has this member method, display monster. Then we're going to define a class called reptilian. Now you see monster here? This is what's called inheritance with classes. And this is what makes classes polymorphic and object-oriented. You can build what's called an inheritance hierarchy with classes. And you can define code on what's called a base class, a parent class, an ADT or abstract data type. And then you can write child classes that inherit from that parent class. They're derived classes, okay, that inherit from the base class or the parent class. Python is I simply pass in the parent object, the parent class that it inherits from, into the, as a parameter to the class definition here. So reptilian will be a class, it'll get everything from its parent monster, all these data members it can access, as well as this member function. But in addition to that, for a monster, a generic monster type, it will have things specific to the reptile class, okay? And this is an example of defining the constructor. The constructor is a function or method that's automatically called whenever you instantiate or build something from a class. So in this case, it'll have additional data members. It gets everything from its parent monster, but it also gets these items here, these data members that are specific, scale armor, nuclear lightning, to a reptilian class object. And in the constructor, we're just going to set these default values. So if we build a reptilian, it'll call the constructor for reptilian, which will then turn around and call the constructor for monster. That's how inheritance works. It moves up and down in a vertical fashion, okay, from parent to child to grandchild to great-grandchild, and so forth. We also have a method specific to the reptilian class, display reptilian abilities. And this is different from, display monster. A reptilian can call display monster because it inherits that function from its parent class, and it can have set display any of these data members because it inherits them from its parent class. But it also has attributes and a function specific to that class of object itself, okay? And we'll also create a class called winged monster, and it also inherits from monster. It's a child class of the base class monster, the ADT or abstract data type monster. And it gets everything the monster has, all the data members and the member method, the function, display monster, but it also gets evasive by location, hurricane, strike, and it gets display winged insect abilities, specific only to a winged insect, in addition to everything it inherits from its parent, okay? So this is a very simple and short inheritance hierarchy. So we have up here, we have a base class, the parent class, and then we have two child classes. Reptilian inherits from the parent monster, and winged insect inherits also from the parent monster, all right? So we have a function here called create players, and we're just going to instantiate player one. Remember, those are our globals up here, player one, player two, and they're initialized to none, which is sort of Python's version of null in other languages if you use null before a bit. So we're going to create these players. What are we going to do? We'll display instantiating a player one object. And player one, it was pointing to none, null, nothing. We're going to build a reptilian, and we're going to pass in a parameter. Well, what happens here if I pass in this parameter, reptilian Godzilla? Well, let's go take a look at it. Here is a reptilian class object. And what happens? It has a default parameter named generic reptilian, but if we pass in an argument, in this case, it will be Godzilla. And then what does that do? In this case, we'll set the class to reptilian, and the name will be whatever we pass in. So we won't use this default parameter in this instance because we are passing in a name Godzilla when we instantiate or we build the reptilian class object. So it calls the reptilian constructor, and the reptilian constructor copies the name up vertically up to the parent class object and sets the monster name attribute to be this value that we pass in. Do you see how that works? So it's moving in a vertical relationship. All right, so from parent to child, and we can set something in the child class and then move it vertically up and set an attribute in the parent class. So inheritance, that enables us to reuse code, do less reinventing the wheel, do more with less code. And another thing we want to keep in mind is try to shift your code, the weight of your code, up, vertically upwards in your inheritance hierarchy. The more attributes, the more methods and things that you define in a well-planned abstract data type, ADT or base class object, the less code you have to define in derived or child class objects. Just something to think about, shifting your code vertically upward towards your base class, okay? We're doing the same thing down here. We're going to instantiate a winged insect. We'll pass in Mothra, all right? So winged insect is a child of monster, and it in the constructor, the winged insect constructor, it can then take the string and pass it upwards in a vertical relationship to its parent class monster and set that name attribute to Mothra. Then what are we going to do? Well, player one, that holds our instance, right? We instantiated, we built a class an object from our class definition. It's been instantiated. Well, it's an instance now of the reptilian class, which inherits from the monster class. And so we're going to call display monster. We can do that because there's a vertical relationship between reptilian and its parent monster. So therefore, we can call the monster, the base class monster method, display monster. But we also have the option of calling the reptilian class, the child objects, display reptilian abilities, which is specific only to a reptilian class object. We can call them both because of inheritance here. And then we're going to simply do this. We're going to take globals player1, and what we're going to take this local instance of player1, and we're going to set it to the global. We're doing the same thing here. Display monster, display winged insect. It's the same idea, okay? And then we're going to take this locally defined instance. We've instantiated the object, we built it, and we're going to pass it up to our global way up here, player1 and player2. So by the time we call this method, we have a winged insect and we have a reptilian, okay? And the reptilian we called Godzilla, and the winged insect we called Mothra. We're going to display their stats, and this is just some formatting code here for the print method. So we want to create columns, okay? Columns here and there. So you can see what that does. That takes these, player 2, monster name, player 2, monster health, monster defense, all the attributes we get from the base class, okay, that it inherits from its parent. We're just taking that and we're displaying it, and we're creating columns here that are this width, this number of characters in width. 14, 8, 9, 8, 11, and 20. So we'll get some nice spacing, and we'll line up columns when we display it in the console. Now we have a function here called monster combat. And in monster combat, we're going to set some default values. And we're going to go ahead and start a magic battle. We'll display combat stats, right? That calls our function up here. It's formatted to display all of our data from the base class. And we're going to flip a coin for who gets to start. Who gets to go first, Mothra or is it Godzilla? Heroine or antagonist? That's what we use on our random number here. So random number, generate a random number between 1 and 2, and assign it to blind chance. That's like a coin toss, right? Heads or tails, 1 or 2. If blind chance is 1, current player is player 1. If blind chance is 2, current player is player 2. Either way, all right? And we'll display heads, good luck, or tails, bad luck. Sleep is a function here. We're just going to pause for 4 seconds so that the player can read the output, and then we're going to clear the screen. System CLS, or if you're running this Python on Linux, we'd say clear instead of CLS, but it depends on the operating system. While player 1 monster health is greater than 0 and player 2 monster health is greater than 0. Remember, and means they both have to be true, both sides of the logical and operator. We're going to keep in this while true loop. We're going to keep combat going. This is a combat loop with individual combat sequences that each object will be able to call, okay? We'll say beginning combat sequence, and we're going to sleep. We'll wait 2 seconds. And then if the current player is player 1, okay, then in this case, player 1, if player 1 monster health is greater than 0, and we're testing this here because if something happens in this loop, we don't want a negative value, or if either Mothra or Godzilla, if their health is 0, we don't want to allow them a post-mortem attack. So we need to test for this condition here. And then if it's the case, as long as player 1 is still alive, their health is greater than 0, their monster health is greater than 0, then we'll say, hey, player 1, whatever their name is, attacks player 2, whatever their name is. And remember that was randomly set up here, because current player could be either player 1 or player 2. A Mothra, a Godzilla, who knows? It's random. So we'll go through and we'll say, we'll print whoever player 1 is, whatever their name is, be it Godzilla, be it Mothra, determined randomly by the coin cost, by chance, attacks player 2, monster name. And damage will generate a random amount of damage between min damage and max damage, which was defined here. And we'll go through and we'll set attack points. And in this case, we'll generate random damage for these attack points based on, in this case, a random measure between 10 and whatever the value is for their attack. So we can have different objects that have different values for attack and defense and so forth. And based on that, we can, alter the algorithm in our attack sequence to do different things based on those values. So this is based on, that might increment based on whether or not they're wearing armor or they've got some special ability in the game, or it might level up with experience and so forth. Down here, we'll also take into account defense, right? And then we'll sleep, we'll wait 2 seconds, and then, we'll subtract whatever defense the opponent has from whatever random damage was generated up here, along with the additional damage that was generated by that particular entity's attack sequence, that monster's attack value or attack capability. So we'll subtract the defense of the opponent, and then display the total resulting damage. If damage is less than 0, damage is equal to 0, because we don't want a negative. We don't want like -5 damage. That would heal the opponent. Although, I guess you could comment this out, and that might make the game fun. You never know. Randomly, they might actually accidentally heal their opponent or something, but it's not what we want in this instance. So if damage is less than 0, damage is 0. We don't want a negative value. We have to prevent that. So if player 2 monster health minus damage is less than 0, we're just going to set it to 0. We don't want post-mortem humiliation. We don't want -1, -5, -10, -100. If it's 0, they're dead. Somebody won, somebody lost. That's all we care about. So hence the decision structures here. And if it's a negative value, we're just setting it to be 0. If it's a negative value, we're just setting it to be 0. Okay? And then else if the current player is antagonist, it's just going to flip back and forth. And in our while true loop, it's going to loop back and forth and flip back and forth between player 1 and player 2. Okay? And then if current player is equal to antagonist, and then current player is player 1. If player is player 2, it depends. So if current player is player 1, hey, they got the luck of the draw. If current player is player 2, they got the luck of the draw. We're just doing the same thing here, okay? And then we sort of have a catch-all. Hey, this shouldn't happen. There should only be a player 1 or player 2 in each block of code here. And then we'll clear the counter, the round counter. We'll display the combat stats, wait 3 seconds. If clear counter, we'll clear the screen, and we'll just say magic battle complete once we break out of that while true loop. And finally, we'll call display combat stats. So let's see how this works. I'm going to clear the console here, and I'll hit F5. All right. So in this case, we instantiated a player 1 object. It's Godzilla. And then set the special abilities and its parent class monster abilities. We instantiated a player 2 object. We named it Mothra. So Godzilla versus Mothra. We set its class and its parent monster class attributes, as well as its winged insect attributes. So they've both been instantiated, built from the class blueprint, been defined, been built in memory. They're ready to go. And now we're going to hit enter to continue. We'll display their stats, and here's our formatted columns. Flip a coin for who gets the first attack. Okay? Beginning combat sequence, Mothra attacks Godzilla. So Mothra got the luck of the draw, the flip of the coin. Mothra generates 9,531 damage. Mothra's attack skills add 1,386. And then Godzilla defends, blocking 1,665 of damage. Okay? But what happens here? Okay, magic battle complete. Somebody wins, somebody loses. Mothra inflicted so much damage on the first attack, Godzilla couldn't counterattack. And that's it. Okay? And here are our closing stats. Mothra wins, Mothra's alive, Godzilla's dead. Reptilian winged insect. Now, let's run it again since this is random and see what happens. We build our class of objects again. I hit enter to continue. Mothra 7,000, Godzilla 9,000. Who gets the first attack? Result heads. Player 1 gets the first attack. So this time, Godzilla attacks Mothra. almost 8,000 of damage, an additional 3,535, and then Mothra blocks 445. That's just not enough. Godzilla kills Mothra in the first round. So now Mothra's dead, and Godzilla survives. And we could play with the stats to create a more challenging or interesting loop there, combat loop. But you get an idea of how it functions, how it works, how we define these classes, how we set up inheritance, instantiate them, and use them in functions and methods in our applications and our programs. Let's take a closer look at this idea of setting up an inheritance hierarchy, okay? Which is where you get a maximum amount of benefit from an object-oriented style of programming. So I have some different class hierarchies here. So here's a map for a game I created called Conspiracy, okay? And this is an example of all the locations on the map where you could go. And here's the class hierarchy for Conspiracy. And it was just based on the idea of taking every conspiracy theory on the internet and what if it were true? You know how they say that the Illuminati run the world and the Luciferians run the world and the Freemasons run the world and Area 51 and aliens and who shot JFK, and there's just so many different internet conspiracies. Whether or not they're all true, we'll never know. But Rosicrucians, Majestic, ATF, FBI, Homeland Security, Watchers and Builders and Abductors and Reptilians and Greys, and goodness gracious, there's all sorts of things going on in this game. But the idea was to take, sort of just make a fun, hilarious, fun type of game where all the conspiracy theories on the internet were true and somehow link them all together in some crazy reality. Well, I had to create a class hierarchy for that game. So in this case, the abstract data type, the ADT or superclass, the parent class object was entity. From that, Freemason, human, and alien inherited. And then from that, we have Freemason good guys who are benevolent. We have Freemason bad guys who are malevolent. And in the benevolent kind, there's a watcher and a builder. And the malevolent kind are Luciferians, Rosicrucians, and Illuminati. From the humans, we have civilian and government. And then from government, we have CIA and Homeland Security, FBI, ATF, NSA. And then from that, we have military. And from military, we have Area 51 and Majestic. So, parent, child, grandchild, great-grandchild, great-great-grandchild, and so forth. We have alien, benevolent, malevolent, abductor, reptilian, gray. Okay, just an example of a class hierarchy that I designed. Here is another one. For one, I did called Mutant Wars. And we had a life form that was the base class, the parent, the abstract data type. From life form, we got mutants and humans. Humans, you had seekers, assassins, and civilians. And then mutants, you had flyers, freezers, healers, mind readers, pyrotechs, time travelers, telekinetics. And then you had super mutants, and they could have multiple abilities. And there was a brain eater and an empath, sort of a malevolent and a benevolent. But just, again, another idea of a class hierarchy, okay? And this was the map for Mutant Wars. This is the map right here for that game. Here is a game that I've done in Python, and this is posted. This game is posted on GitHub. You can download the source code, and I did a video explaining this game. There's both a console version and there's a GUI Tkinter version of this game. But again, the class inheritance hierarchy for the RPG game, the role-playing game Discord's Dungeon. So for the base class, the parent, we have game entity. That's our abstract data type. And then from game entity, NPC, antagonist, and pony all inherit all the data members, all the code, all the capabilities, all the functions of a game entity class object. And we shift that code vertically up into the abstract data type, into the parent object. Okay, so no need to reinvent the wheel. We can reuse all that code whenever we build these classes of object, NPC, antagonist, pony. They're all children of the parent class game entity. And then we further derive and inherit. We create a grandchild, chaos agent. It inherits everything that antagonist has, as well as everything that game entity has. Then there's the pony class. Yes, it inherits everything that game entity has, but also we have alicorn, unicorn, and pegasus. They're grandchildren. They inherit everything from the child class pony, which inherits everything from the parent game entity. And even for the alicorn class, we have a great-grandchild class object. It inherits everything the grandchild has, which inherits everything the child has, which inherits everything the parent has. So do you see that vertical relationship, how inheritance works in a class inheritance hierarchy? It enables you to reuse lots of code to do a lot more with a lot less code. Uh, you know, just a something that you'll find in typically any object-oriented language there. Example of an inheritance hierarchy. And in addition to the inheritance hierarchy, here is the map for Discord's dungeon. Okay, so just an example of the map there. And to see how that inheritance hierarchy is defined, all this code is on GitHub, but we'll just go through the code real quick in that project. And let me go to RPG Game Discord's Dungeon, and we'll want version 20 down here. Okay. Go all the way up to the top here. So look, here's our parent abstract data type base class game entity. And all of this code here, all these data members, we have defined it. And there's a whole video explaining how this game works. So I'm not going to waste time explaining things here, but I just want to show you. We have a cheat mode method. We have all these functions and methods in the parent class. There's an attack, inventory display, inventory equip, inventory use, magic skill display, magic skill equip, magic skill use, display all those items. Let me go down here. There's an attack method. Here's an attack method, which takes into account lots of different items that they use, and all of this is in the base class object. So everything we build from this base class, this parent class, all the children classes inherit all this code. So it's not something, we don't have to reinvent the wheel. We don't have to needlessly repeat code that we've already defined in the parent object. Okay? Then we have a class antagonist, which inherits from game entity. Then chaos agent, which inherits from antagonist, which inherits from game entity. So again, vertically up the hierarchy, it gets all the code from its parent and its grandparent and its great-great-grandparent, if that be the case. Okay? Then we have pony inherits from game entity. Alicorn inherits from pony, which inherits from game entity. Unicorn inherits from pony, which inherits from game entity. Pegasus inherits from pony, which inherits from game entity. And Princess inherits from Alicorn, which inherits from Pony, which inherits from game entity. So it gets all that code, gets to reuse all that code, all those functions, all those data members. And it's just a more efficient way to create a larger and more sophisticated project using and planning your code around an inheritance hierarchy. And when you're going to code something like this with classes and an inheritance hierarchy, you plan that out, you chart that out first before you ever start coding. Just showing you what that looks like in the code. Let's take a look at another example. And in this example, the same imports, the same player 1 and player 2 globals. We define the base class, the parent, the abstract data type class monster the same way. Same data members, same function or method. We have a child class which inherits from the parent monster. It gets all of the data members, all of the methods, in addition to these data members specific only to a reptilian class object. This is the constructor. Remember, it's underscore, underscore, net, underscore, underscore. That's the way it always is in Python. And also, do you see this self here? I haven't talked about this yet, but often when you define a function inside of a class or a constructor, you will accept self as a parameter, as an argument within the list of arguments supplied to that method. That self, it functions like the this pointer in C++. It allows you to get at data members or values or functions defined statically within the class itself, okay? So you don't have to, but usually 95% of the time, you're always going to include self as an argument in every single function and method, including the constructor that's defined inside of a class. All right, so just remember that's underscore, underscore, init, underscore, underscore. Not always, but most of the time, always you will have self as an argument. In addition to, you can have other parameters, other arguments, and you can specify default parameters, as we did in this instance. Okay, so you get everything from the parent monster, in addition to these data members, these attributes, and this function here is specific only to a reptilian class object, just like we did before. We have a winged insect. It too inherits from monster. It gets everything monster has and everything monster does from its parent, but also it has these data members and this function that's specific only to a winged insect class, okay? We're going to go through, we're going to create players. We'll instantiate a Godzilla. Well, it's named Godzilla, but we're instantiating it in a reptilian class object. We're going to hold that instance, it'll be player one. Player one will point to that instance, the object that we build from the reptilian class, which inherits from monster. We'll call display monster from the parent class and display reptilian abilities from the reptilian class itself. And then here we're going to set our global, sort of our little pointer variable up here, which is pointing to nothing, to null. Now it's going to point to and hold on to that object that we built, so it will persist in memory when we exit the function, okay? We're doing the same thing down here. That was Godzilla from the reptilian class. Now we're building, once again, Mothra from the winged insect class. We'll call display monster from the parent class. We'll call display winged insect abilities from the winged insect class. Just to show you we can get both of them, we'll take the local player 2 and we'll cause it to point to the global player 2 way up at the top there, right? And that way these two objects will, even though this function, when it ends, everything falls out of scope and all the objects are destroyed, those objects will persist in memory because we set up those two globals up at the top to point to them, to hold on to them, okay? When we say enter to continue, input, just continue, we're not doing anything with it. It just catches that baseball that's thrown from the return value of input, but just a way of kind of making it pause till they press, hit enter. And then we will what? We'll clear the screen. Display combat stats. Again, we're formatting columns, and this is the character width. And if you look over here, the attributes, the data members here, okay, from the parent class and from the derived class. So the defense, the health, the dexterity, okay, the name of the monster itself. Now we have monster combat. Minimum max damage, same, current player, nobody. We're going to go through display combat stats. That calls this method up here, which formats everything in nice columns. Magic battle, monster name versus monster name. All right, so player 1 versus player 2, Godzilla versus Mothra. We're going to flip a coin, generate a random number between 1 and 2. And that's like flipping a coin, right? This is random, 1 or 2, heads or tails. If it's 1, if blind chance evaluates to be 1, current player is player 1. Player 1 gets to go first. Woohoo! Good luck. Player 1 gets first attack. If it's 2, if it's not heads, if it's tails, then player 2. Current player is player 2. Bad luck. Sorry, player 2 gets first attack. Player 1 has to wait. So that that gives one of our players a random advantage. And then this should never happen. Well, it should only either be 1 or 2. No other values because of how we generated the random number up here, right? We'll clear the screen. And here's our combat loop sequence, okay? Monster health. All right, so again, and logical and, both sides have to be true. As long as player 1 is still alive, health is greater than 0. And as long as player 2 is still alive, health is greater than 0. We'll continue iterating through this while true loop. Begin the combat sequence. We'll count the rounds. We'll sleep. We'll wait for 2 seconds in the console. If in our little coin toss, right? If current player is player 1, ooh, luck of the draw. Look at the coin toss, then player 1 gets to attack first. Now, inside the repetition structure in the loop, we need to test to make sure that player 1 is alive. their health has to be greater than 0. If something happens and they get killed and we're locked in this while true loop, we don't want to allow them to post-mortemly attack the other player, the other object. So we have to test for that. They can only attack if their health is greater than 0. So just with that caution there, we need to test for that. Player 1, their name attacks player 2, the opponent, and their name. All right, so say it's Godzilla. Godzilla attacks Mothra. Or say it's Mothra. Mothra attacks Godzilla. That's what it'll display. It'll wait 2 seconds. It generates a random amount of damage that's based on min damage and max damage, which were defined up here, right? So anything between 500 and 10,000. Then, based on the attack value, so in addition to the random damage that gets generated up here, there is a random amount of attack damage between 10 and whatever the attribute value for the attack is for that monster class object. So different monster objects could have different attack values. One might be really weak and only have an attack of 5, or let's say an attack of 20. So it'd be between 10 and 20. Another one might have an attack value of 1,000. It's like a level boss. So it'd be between 10 and 1,000. Much more damage would be added on in addition to the random damage, the attack damage, which could be different for every single monster based on how weak or how strong they are by setting the attack value. So we add that to the random damage, but then there's a defense amount of damage, right? So damage is damage plus attack points, but what? The opponent gets to defend themselves, and they have a defense value. And whatever their defense value is, it's going to randomly subtract. It'll generate a random defense between 10 and whatever that opponent's defense attribute value is, and then subtract that from the damage. So that's how they defend. That's how they mitigate damage there. And are a very simple algorithm. We'll wait 2 seconds, and then if damage is less than 0, we don't want negative values here. We don't want negative 10 damage or negative 50 damage. What does that even mean? Does that mean that they heal their opponent? We don't want that, right? Or maybe you do, but in this case, we don't, not in this game. So what we want to do then is if we detect a negative value, if it's less than 0, just set the value to be 0. And if monster player health minus the damage is less than 0, then just set it to be 0. Once they get to 0, they're dead. We don't want negative values. We don't need post-mortem humiliation here. We just want, all we're interested in is if it's less than 0, just make it 0, okay? So that's all we're doing here, all we're doing here. Else, otherwise, if that's not the case, and they have enough health to actually subtract the damage, then we'll subtract the total damage minus the defense from the opponent's health, okay, in the attack sequence. And then otherwise, hey, if this is not true, this if up here, then this else, okay, well, then in this case, this player can't attack anymore. They lost. They no longer have a positive health value. It's been set to 0, right? So that's what happens if current player is player 1. This block of code does the same thing, but it's just inverse if it happens to be player 2, right? Whoever won the coin toss, whoever won the coin toss, that decides which block of code gets executed, okay? And then it just flips back and forth inside of our while true loop, right? So current player was player 1, and then current player becomes antagonist. Or current player was player 2, and down here, current player becomes heroine, okay? So heroine, antagonist, antagonist, heroine, whoever got to go first, and it flips back and forth until somebody wins and somebody loses. And we're just going to count the combat round. We're going to pause for 3 seconds, clear the counter, clear the screen. When it's all done and we bust out of that while true loop, somebody's dead, somebody's still alive, somebody lost, somebody won. We'll say magic battle complete. And then we're going to look at it and say, hey, well, if player 1 health is greater than 0, well, they won. Because the only other possibility is player 2 lost, right? Their health is 0. Otherwise, player 2 is victorious because player 1 lost. And then we'll display the closing or ending combat stats, okay? It's just an extension of the first idea, the first game, but let's clear the screen and let's hit F5 and run this. Okay, instantiating a player 1 object, Godzilla. All right, and there's the inheritance hierarchy, moving vertically up our inheritance hierarchy towards the parent class, inheriting. Now we instantiate a Mothra, Again, it inherits everything monster has, its parent, as well as things specific to winged insect class. We're all ready. We've built our objects, instantiated them from the defined classes in our inheritance hierarchy. We're ready to go now. Let's plug them into the combat loop. Hit enter to continue. We hit enter to continue. Here's the formatted columns. We flip the coin. Looks like player one gets lucky, gets the first attack. So beginning the combat round, Godzilla attacks Mothra. Does 9,985 worth of damage, an additional 3,156 by its attack, and then Mothra blocks 965 with its defense. Mothra dies. Okay? Magic battle complete. Godzilla is victorious. They defeat Mothra. Okay? So, let's try it again. As it's random, let's see what happens this time. Again, we build or instantiate our objects. We hit enter to continue, clears the screen, formats it in columns. All right, player one gets first attack. Godzilla attacks Mothra again. Almost 7,000 damage. Another almost 4,000. Mothra's dead. Only defended 317. Okay. So let's run this now and see what happens. And I'm just going to drag this up here. Going to hit F5. So here we are. We build our Godzilla, right? Which then goes up the inheritance hierarchy and inherits everything the monster has. We build our Mothra. Goes up the inheritance hierarchy, inherits everything the monster has. In addition to what it gets by inheritance, Godzilla gets all the things specific to a reptilian class object, and Mothra gets all the things specific to a winged insect class object. Our objects are built, they're ready to go, so let's enter to continue. Plug them into our attack sequence. Formatted columns, we display the stats, flip a coin, who gets the first attack? Player one gets first attack. Okay, so it looks like Godzilla's lucky. Godzilla attacks Mothra, 7,107 damage, additional 1,763 damage. Mothra blocks 1,431 via defense. But Mothra's dead. Mothra's 0. Godzilla won this round.